Hi, welcome to Video Math Lessons. Tonight we're going to do a Math 12 pre-calculus lesson. The topic will be exponential functions, and we will be talking tonight about Newton's law of cooling. So the first thing we have to know is if we had like a coffee cup and we were talking about a liquid cooling off while it's sitting on the table, right? So we have a coffee in a cup, take it out, it's hot, it lets it sit for a few minutes, it cools down. Well, there's a law for this, and it's called Newton's law of cooling. So Newton's law of cooling is given to us as this. So T of T equals Tm plus T initial Tm e to the negative kt. So we have to know what all these pieces are. So we have T of T, and that's just the temperature at any time. We have Tm, which is the temperature of the medium. And the medium is just the surrounding fluid. So it could be air, it could be water, whatever they're using as the medium. We have T initial, that's T0, which is time at time 0, T0. That's the initial temperature. And Tm is still temperature of the medium. E is the natural base. Little t is time. And K is our coefficient of cooling. So whatever it is. So we're actually doing problems from our textbook. We're going to do problem number, so it's page 332 in our textbook. And this question that we're going to do right now is question number 49. And it's about a cup of coffee, 90. So here's the story that they give us. And what you have to do is you have to take the initial givens. First thing, you have to find the K value. So that's first. Then find the T value. So it's a two-part problem. So here's the initial conditions. So let's write these down. We have it cools from 92 degrees Celsius down to, what does it say, 50 Celsius. And it takes 12 minutes. The room is 22 degrees Celsius. And so that's the initial. So that's the first part. We're going to use this to find K. Then the second part is this. How long until the coffee is 30 degrees? So how long until coffee is 30 degrees? So we'll do this in two parts. So this is the first part and the second part. The first part is we're going to use our formula. So we got this whole formula here. So I'm just going to rewrite the formula. So T of T equals temperature of the medium plus parentheses temperature initial minus temperature of the medium e to the negative coefficient time. So we're going to plug in, and we're going to plug in all our information here. So now for this first part, the temperature at the end of the time is the 50 degrees. So that's going to go here. So it's 50. Temperature medium is 22 plus 92 is the initial minus the 22 e to the negative k, because I don't know what it is yet, but I did know it took 12 minutes till it got to this temperature. And what we're going to do now is going to clean this up, and it's an exponential because the variable's up the stairs, and we're going to solve it. So 50 equals 22 plus 70 e to the negative, I'm just going to switch that around to negative 12k. And we're going to solve this thing. So we have to move over to 22. So this is going to come over. So I got 28 equals 70 e to the negative 12k. We divide. So this 28 over 70 equals e to the negative 12k. To get the variable down, we take the natural log. So it'll be ln 28 over 70 equals negative 12k ln e. Now I'm ready to use a calculator. So what I want to do is I want to move this 12K over. But what I'm going to do is I'm just going to punch some numbers in the calculator. So get your calculator. And so we're nice and easy. So ln 28 divided by 70. Close. And I'll hit enter now. So it's a little bit safer. Divide by negative 12. Enter. And divide by ln 8. So far I have this. So now divide by natural log of 8. And the e is over the division symbol. And what you should notice is you get the exact same answer as I had before dividing by ln 8 because the natural log of e is 1, so it doesn't change it. But if you weren't sure about that, then make sure you divide by the ln of e also. So we come up with a k value and so it's all those decimals, 0.076357561. And usually we round to 4 decimal places, so it's 0.0764. Now the only thing is this. If I use the 4 places in the new part, your answer is not exactly going to come out, it's going to be off a little bit because you're supposed to use all the decimals. You don't round until the end, technically. But what I can do is I can store this information into the calculator. So I'm just going to press the button that says store. So I have the decimal on the screen. Press store. It's saying answer arrow, and I'm going to put it in for the x value. So what I just did now is I stored it for x. So anytime I press x, it'll be 0.0763, the whole decimal. So now I'm going to redo the problem. So now we're going to redo. So we'll slide this over a little bit. Slide this over a little bit this way. And let's do it again. All right, so I'm going to write down my formula. So T of T, so that's the temperature at any time equals temperature of the medium plus initial minus medium temperatures, e to the negative KT. And we're going to plug in our variable, our information. Now, all this stuff is going to, a lot of this is going to stay the same. So this final temperature now is, when is it going to be, what they ask us, 30 degrees. So I want 30 degrees now. So 30 is here. But a lot of this other stuff will be the same. So 22 plus 92. If you wanted to put the 70 now, I'm fine with that. E to the negative. All right, now this is where it's going to get good. This is where the decimal is, 0.0764 to the T. Now, we're going to solve this. Subtract 22 from both sides. So I got 8 equals 70, e to the negative 0.0764 T. Divide 8 over 70 equals e to the negative 0.0764 T. Natural log ln 8 over 70 equals 0.0764 T ln e. We're going to use a calculator. Now, so far, I haven't used the calculator yet. So now we're going to use the calculator. So natural log 8 divided by 70. Close it. Hit enter. Divide by negative here, negative point. Now I don't want to type in that, I want the x. So negative x, and it'll use the decimal that we had stored. I get 28.4. I could type in natural log of e, but it does not going to change it. So my answer is 28.4065346.3. Now if they don't tell us where to round to, it's 4 decimal places. But for this problem, we're going to round to the nearest hundredth. So I am telling you, we're going to go to 2 decimal places. So our final answer is, so we're going to round this to 2 decimal places. So my final answer is T equals 28.41. And the time was given in minutes to start with, so it is in minutes. A lot of work. It's a big question. let's try it again. So question 50. They say you take a cake out of the oven. The temperature to start with is 350 degrees. Now we're in Fahrenheit this time. And what happens is in 20 minutes, it cools down. It cools down. It cools down to 60, what does it cool down to? 120 degrees. So this is the question number 50. So 20 minutes, the room temp was 65 degrees. Now the question is, how long until the cake is 90 degrees? So that was the question they gave us. So we're going to write down our formula. So temperature at any time is equal to the temperature of the medium plus temperature initial minus temperature of the medium, e to the negative coefficient, the k value, the constant, it's coefficients, the coefficient of cooling, kt. And it is constant for this, whatever you find the constant of this k, it's going to be constant throughout the problem. So we're just going to plug in. And let's see here. So the temperature at the end was 120. The room was 65 degrees. The temperature it started out was 350 minus 65 degrees. E to the negative k. We're looking for k first. And it took 20 minutes. I'm going to clean this up. Actually, I'm going to do a couple things. I'm going to move the 65 over at the same time. So it's 55 equals, put this stuff together, 285 e to the negative 20k. And we have our nice exponential now. You could do this also graphically at this stage if you wanted to, but we're going to do it with logs. So 55 over 285 equals e to the negative 20k. Natural log both sides. Ln 55 over 285 equals negative 20k ln e. Use our calculator. Ln 55 divided by 285. Enter. Divide by negative 20. Enter. And I come with 0.082. And if we go, I'm just going to write down 4 places. K is 0.0823. Now, I want to use all the decimals, so I'm going to store this for x. So store x. So when I redo the problem, what I'm really looking for, when is it going to be 90 degrees? So, got my equation, T at T, Tm, T initial, Tm, e to the negative kt. I'm going to plug in numbers. 90 equals, and a lot of this is going to be the same, 65 plus, might as well put it into 285 now, e to the negative 0.0823. But once again, we will use x when we do it. I'm going to move this over. So we get 25, 285. Divide. Natural log. And calculator. Ln 25 divided by 285. Enter. Divide by negative point. Oops. Almost fell for it. I don't want that. I want the x value. So negative x, which would be all of our decimals. enter. If I divide by ln e, it doesn't change anything, right? So I move this over, you get rid of this. So our final answer is t equals 29.59. And the problem was in minutes, so it's still in minutes. And that's it. Well, hope this helped. And yeah, come back. Thanks.